Okay, here we go on our first test for the people who had the second version of it. I'm going to start off with our fractions here. Let me zoom in on our problem a little bit more. Try and do two. So our job was to write the answers in simplest form for each of these things. So, in order to add or subtract fractions, you have to have a common unit because adding and subtraction are just like counting up terms. The common unit when it comes to fractions is the denominator. That's what you're measuring it with respect to. Okay, so we have 9 and 3 in the denominator of number 1. Least common multiple between those two would be 9, which means my 3 over here, I would have to multiply by 3 on the bottom. Now I want to not change the value of this fraction here, I just want to change what it looks like so that it's got that 9 on the bottom. Well, the only number I can multiply that won't change value is 1. Well, by putting a 3 on top of that 3, there is a 1 there. What that gives me is 7/9 plus 16 times 3. Well, 10 times 3 is 30, 6 times 3 is 18, so 48. 3 times 3 is 9. Now that I have a common unit, being ninths, I can count up how many ninths I have. 7 plus 48 is going to give me 55 ninths. And I can't simplify because the only factors of 9 are 1 and 3, and 9 itself, none of those go into 55. So I can come over onto the next question, and the same thing's happening. I've got two different units I'm trying to compare or count up, positives and negatives, and unfortunately they don't have the same unit, so I've got to convert them to having the same unit. Trick on there, if they're both prime, just multiply by each other. Now notice I didn't do a cross multiply because again, when we're getting common denominators, we're not changing the value of it. I really need to multiply this by a value of 1, which is 9 over 9. This one I'm going to multiply by a different value of 1. These are both 1s though, so the value of our problems has not changed. I just did something on accident, and it looks like we'll just have to deal with it. Sorry that those got shifted. So on the top we'd have 2 times 9, which is 18 on the bottom. 9 times 7 is 63. On the top of the other one, 4 times 7 is 28. 9 times 7 is 63. 18 minus 28, well, I've got 60/3, so my answer is 60/3. That's what I'm measuring with. And 18 minus 28 would give me negative 10 as a final answer. Moving to number 3, we've got multiplication of fractions, which guess what we just did by multiplying top and bottom. Notice the tops got multiplied together and the bottoms got multiplied together. Same thing. 2 times 3 is 6. 7 times 12 is, well, 10 times 7 is 70, plus 2 times 7, which is 14, so 84. I notice those are both even, so I'm going to go ahead and divide top and bottom by 2. I have to do it to both, so that I'm not changing the value, because 2 over 2 is equal to 1. Dividing by 1 doesn't change the value. All I'm doing is simplifying here. So whenever you're simplifying, you're not wanting to change value. 3 and 42. And I gotta think really quick. I feel like 3 does go into 42. 3 times 14, I think. 4 times 3 is 12. 1 times 3 is 3. Oop, sure enough. So go ahead and simplify it again, not changing the value. I'm just dividing by a different looking 1. And I get 1/12 for my final answer. Okay, last but not least, we have division. Anytime you see any division problem, regardless of if there's variables in it or just numbers or whatever, you can turn them into two fractions if they're whole numbers by putting the fraction over 1, And division is the same thing as multiplying by a reciprocal to get the same value. That's as if I said, if you have, let's do $8, would you rather have your $8 cut in half, have the amount cut in half, or would you rather get half of mean times the $8? Two different ways of saying the same thing, okay? And 2 and 1/2 are reciprocals. That's why I'm talking about that. So we're going to keep the first one. This is where the keeping comes in. Change it to multiplication. And we're dividing by the second one, so that's the one we multiply by the reciprocal. I don't know why I put 1 on the top. 2 over 21. Okay, now it becomes just like the last problem. 7 times 2 is 14. 6 times 21 would be 126. Those are both even numbers, which means I know we can divide them both by 2. I don't have room to put that, so I'm just going to do that in my head. 126 divided by 2 would be 63. Nope, sure enough. 1/9, right? We just did a 7 and a 9 makes 63 when you multiply them. And so 1/9 is our final answer. Okay, solving equations, our goal is to get C alone here, getting rid of what's further from it, because you always want to do your subtraction and addition first. Those are the easier ones to take care of, and you do only have to do each of those once to each side, whereas multiplication and division would have to be done to every single term. C over 7 would then equal 21. Now ask yourself, if you get stuck on these, then it's going to help us out on the next one. What is this saying? What it's really saying is, what number divided by 7 equals 21? Some of you may have been tempted to put a 3 in there, because 3 and 7 are associated with 21. Well, that's not actually going to be your answer. What number divided by 7 equals 21? That means C is going to have to be way bigger than 21. Actually, it's going to have to be 7 times bigger than 21. 7 over 7, if I rewrote this as 7C over 7, well, 7 over 7 is 1, and 1 times C is just C. 21 times 7 would give us 147. That's our final answer. On the next one, got a couple of tricky things. First, we have these parentheses with the minus signs. Parentheses, when you're talking about subtraction and addition, are not really necessary. You'll see it whenever you have a minus and negative, just for cosmetic reasons. Meaning that's just conventionally what we do when you see that. So if I were to rewrite this, get rid of the parentheses and stuff, I know minus and negative is plus, so what we have is 16u plus 4, 16 over u plus 4 equals 12. Well, first thing, easiest thing to get rid of is dividing both, or excuse me, subtracting out a 4 on both sides. Okay, now 2 might pop into your mind, because you know 8 and 2 are associated with 16. Well, let's ask ourselves the question, because some of you tried dividing out 16 on both sides. If you divide out 16 on both sides, you'd still have a u in the denominator. You did nothing about getting that out of the denominator. And 1 over u is not the same thing as regular u. Just like 1 over 2 and 2 are not the same, right? Would you rather find half of $1 on the ground or $2 on the ground? Different values. Okay. So what this question is asking us is, what number I should reword that. 16 divided by what number equals 8? And nice thing about this one, it actually is 2 this time, right? But how do we get that and show that algebraically? Because our teacher always wants us to show work, right? Okay, well, one of the ways we saw with the trig problems is anytime you have a variable in the bottom, and you've gotten it down so you have no more addition or subtraction, go ahead and turn it into a proportion. 8 over 1, that still has a value of 8. 8 divided by 1 is still 8, so we haven't changed the value. And now we do our cross multiply. 16 on this side, 8u on that. Okay, well we want to get that 8 over to the other side. Well, 8 divided by 8 equals 1, and 1 times u is u. 16 divided by 8 is 2, and that's how we could show algebraically. Our last one on this slide is the system of equations problem. And with this problem, we have, first thing that I see that stands out right there is that we have a variable almost all the way alone. So I'm going to choose to solve this one using substitution by isolating that variable. When I do that, what I would have to do is get this negative 5a over to the other side. To do that, I would do the inverse operation. So that would give me x equals, and traditionally we put the variables in the front and numbers at the back. If you had written negative 3 plus 5a, still has the same value. Okay, now that I have that, what I'm going to go ahead and do is take this expression that x is equal to and substitute it in the place of x in my first equation. So let me change colors so that we see what's going on. So when I rewrite that first equation, and I'll put another arrow here, we have 3a minus 3. Then we're going to drop x in, and I'm going to do that back with the orange just to help us see it. Notice it's 3 times x. It's not 3 times whichever part of x we happen to put first. It's 3 times the whole x, so that indicates that we have a distribution going on. Okay, we have a 3a minus, and I would suggest here, to avoid having issues with that, put a plus and negative, so you remember that negative also gets brought in. So minus 15a, because negative 3 times positive 5 is negative 15. Then negative 3 times negative 3 is going to give us positive 9, and that equals negative 3. Okay, combining like terms, positive 3 minus 15 gives us negative 12. Subtracting the 9, negative 12a equals negative 12. And I bet you can guess what a equals. A equals 1. You know what's nice about that is that makes solving for x super easy. So you kind of go in this circle with systems. When we plug 1 in there, what we get for x is 5 times 1 is 5 minus 3, well, 2. X equals 2. So there is the solution to our system. X equals 2, a equals 1. Okay, what we've got here, whoops. Okay, what we have here is 512, which can be broken into 2 times 256. 256 can be broken into 2 times 128. I'm going to go ahead and pull out that couple. 128 can be broken into 2 times 64. 64 can be broken into 2 times 32. If it's all right with you, I'll bring that one out. (32) is 16 times 2. 16 is 4 times 4 times, and then we have our 2 still. And bringing our couple out gives us a final answer of 4 times 4 on the outside, which is 16, and a root 2 left inside. On number 9, same process. We have a 7 out front. 96 is 2 times 48. 48 is 2 times 24. I'll go ahead and bring that couple out. 7 times 2 outside. 24 in. 14 is what outside becomes. 24 can become 4 times 6. 4 is 2 times 2. And we have a 6, which is 2 times 3, but I can already see that's only going to be enough to use for one couple. So on the outside we would have 2 times 14, which is 28, and a 6 left over on the inside. On number 10, following the same process, we've got negative 4. Outside 192 would be 2 times, let me see, well 180 would be 90, so 95 plus 1 more to make the half of the 2, so 96. Double check that, I'm tired. 9 times 2 is 18, 19, yes. Okay, so 2 times 96, then we have m, 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 m. I'll go ahead and bring out the couples. So we have negative 4 and 2 factors of m, so m squared. 2 times 96, well 96 can be broken into 2 times. What did we just see earlier? 48. Bringing out this couple, we have negative 4m squared times 2 with a 48 on the inside. Now we have negative, oops, I hate it when it does that, when it moves all my stuff on me. Negative 8m squared, 48, I can continue breaking, but I know a shorter way, 16 times 3. We'll go ahead and move up over here. Negative 8m squared. Oops, my mistake. I forgot my loner m on all of these. We have 4 times 3m. Bringing our couple of 4's out, we would have negative 32, because 4 times negative 8 is negative 32. M squared with a root 3m. On 11, order of operations says to start inside. With addition and subtraction with square roots, they have to have a common number under the square root, under the radical. These don't, so I can't add them, which means I'm going to go ahead and jump right into distributing. What that would give me is 2 root 5 times root 7 plus 2 root 5 times 4. Outside with outside, inside with inside. 5 times 7, those are both primes. There's no factors coming out there. And since these do not have the same number under the radical, that's as far as we can go. On number 12, same process. Those don't have matching numbers. There's no distribution, so I wonder what I could do. Well, I know 32 is 16 times 2. 16 is 4 times 4. And then we have the 2. So that root 32 could be broken down to 4 root 2. What a coincidence. We now have matching numbers under the square roots. So that's like I have 4 root 2 minus 5 root 2, or 4 inches minus 5 inches, or 4 thirds minus 5 thirds, whatever your unit is, inches, fractions, square roots. My answer will be negative 1 root 2, or just negative root 2. Oh. See, it took away that stuff over there, but not what I wanted it to. I really don't get it. Whatever. Okay, on 13, my suggestion to make your life easier on these is to simplify out without, in within. 3 and 2 can't simplify, so I'll just leave them. Inside, we have 27 and 9. Well, dividing both of those by a root 9, so it doesn't change the value because we're simplifying these expressions. And this is a value of 1. What we would get is root 3 on the top, and then 1 on the bottom. Well, 1 times 2 is 2. And we can't simplify any further. There's no square root in the bottom, no common terms. That's our final answer. Okay, on these ones are special angles. The trick on this, part of it was remembering their names. Your options are alternate interior, alternate exterior, corresponding, consecutive, interior, which is also known as same side interior, and then we also had our other two random ones, vertical angles and linear pair. So looking at our picture, we're talking about angle 4 and angle 5. They're both inside our parallel lines on the same side of the transversal, which means these would have to be same side interiors. And we know the relationship between those is that they are supplementary. Or in other words, angle 4 plus angle 5 equals 180. Substituting for their values, we get 5x squared plus 110 equals 180. Subtracting 110 from both sides, we get 5x squared equals 70. Dividing 5 from both sides, we get x squared equals 16, and then taking the square root from both sides, x equals positive or negative 4. We haven't really been worried about that, so you can leave it as at positive 4. Okay, on the next one we have angle 6 and angle 2. They are not both outside or both inside, so our interiors and exteriors are not an option. They aren't doing our little V's that vertical angles do, so they're not really that. Together they aren't making a straight line, so corresponding is the only option. Well, if there are two intersections, they are both in the lower left-hand corner or in corresponding slots, so that is the correct answer for the type. I'm going to be lazy and abbreviate. We know the relationship between corresponding angles is that they are congruent. What congruent means is they have equal measures. So if I replace angle 6 with its measure and angle 2 with its measure, those two would be set equal to each other. Our job is to get x alone, so we need to divide by 3. Dividing fractions. Good thing we practice up at the top. That 3 is the same as 3 over 1. 4/3, keep change, flip. Dividing by 3 is the same as multiplying by its reciprocal, 1/3. On the right hand side, 3 divided by 3 here is a factor of 1. 1 times x squared is x squared. So what we end up getting, and I'm just going to come up over here, is 4/9 is equal to x squared. Square rooting both sides, we would have root 4 over root 9, which happens to turn out to be 2/3. Special right triangles, I'm just going to put our rules over here that I'm going to be referring to. 45, 45, 90 here. Legs are the same length. Hypotenuse is the leg times root 2. On our 30, 60, 90, 30 is across from the short leg, 60 from the long leg, 90 hypotenuse. We always get the short leg first, which is referred to as x, whatever variable you want. To go from that to the long leg, we multiply by root 3. You divide to go backwards. To get from the short leg to the hypotenuse, we multiply by 2. To go backwards, we would divide. Using those rules, number 16, I have a 45, 45, 90. I know that because the two legs are congruent. I know that because they are given the exact same variable in the same problem. I have the hypotenuse because it's across from the 90-degree angle. So if I wanted to get either one of the legs, I would take the hypotenuse and divide it by root 2. I want exact form, which means now typing that in the calculator. Basically what that means, I need to rationalize. Multiply by a factor of 1 that gets rid of that square root in the bottom. Well, that would be root 2 and root 2. That gives us 18 root 2 over 2. Uh-oh, 18 and 2 both outside can simplify down, and we get 9 root 2. On the next one, we have the leg. We want the hypotenuse. Rule says multiply by root 2. Root 6 times root 2 equals root 12, which can be broken down to 4 times 3, which is 2 times 2 times 3. And I'm sorry, I'm going in a circle. 2 root 3 is our final answer. Number 18, 30, 60, 90. This is the short leg because it's across from the 30-degree angle. Hypotenuse across from the 90-degree angle, which means this has to be the long leg. If I have the short leg and I want to get to the hypotenuse, I multiply by 2. 14 times 2 equals 28. And that's the answer. On number 19, I have the long leg because it's across from the 60. Which means this has to be our short leg because it's definitely not the hypotenuse. And going from a long leg down to short leg, I divided by root 3. Just like number 16, can't leave that root in the bottom. Multiply by a factor of 1 that would get that root out of the bottom. Or cancel, I don't want to say cancel, but make it so we don't need the root anymore because root 3 times root 3 is regular 3. On the top we have 12 times root 3. Now, just like that last one, 12 divided by 3, our outsides simplify, and we get 4 root 3. Last but not least, on our special right triangles, we have another 30, 60, 90, only we have the hypotenuse and we want the long leg. We've got to get to the short leg first. So hypotenuse to short leg is root 6 divided by 2. Can't simplify that any further, so there's our short leg. Multiplying that by root 3, well, notice I'm multiplying it by root 3 because the formula says to do that. I'm not simplifying this root 6 over 2. So when I multiplied it by root 3, it is root 3 over 1 because I am intending to make it a bigger number or change the value. Whereas over here, my answer is equal to 12 divided by root 3. If I type this, or this into the calculator, they will all come out to be the same number because all I'm doing is simplifying, not changing the value. Here, root 6 over 2, this shorter side is not going to turn out to be the same number as the longer side. That wouldn't make sense. One's longer, it has a longer length, and that's what we're measuring. Root 6 over 2 times root 3, well, inside times inside. I'm going to go ahead and write my 6 as a 2 times 3. And then I have another 3 here, over 2, just to save us some steps. We would get 3 root 2 over 2. And we can't simplify any further. Okay, on to our last 3 questions. Trig, the most recent thing we needed to remember is that side lengths can be called by their geometric coordinates. So this bottom side here could be called side AB. It can also be called using a single lowercase letter, and that letter corresponds to the angle across or opposite the triangle from it. So this same side could be called side AB, or it could be called side little c. Okay, little a would be here, little b would be there. So on our picture, the side we're looking for is this one. Okay, well, given our reference angle, always use what's given right there. Reference angle, we have an 8, well that's opposite. This one is going to be hypotenuse. So SOHCAHTOA would then say, well, we have an opposite and we want a hypotenuse. Sine is the trig function that will do that for us. Trig function of the reference angle is is equal to opposite, which is 8 over hypotenuse. Uh-oh, there's that variable in the denominator. That is not the same thing as 8 times h, or h divided by 8. Okay, so this was one of the ones where we said we got to get it out of the denominator. Let's turn it into a proportion. Multiply both sides by h. It's essentially what we're doing. That the h's would simplify to a factor of 1 on this side, so then they wouldn't be there anymore. 8 times 1 is 8. Okay, we got to get h alone. Sine of 49 is a single number, just like 3 is a number. This one just happens to be uglier. I don't know why I put 43. Oh, because I said 3. Okay, sine of 49 divided by sine of 49 is 1. h times 1 is h. And then when I type this in my calculator, oh, I don't have my calculator with me right here. Okay, when I type that in my calculator, I get 10 point, what am I rounding to? Tenths place. Ones, tens. On the other side of the decimal, we have tenths, that's the trick. And then hundredths, so I'm cutting it off right there. 10.6 is my final answer. Solve for side A. Well, little a is opposite big A. And we'll use that as our reference angle. This is going to be, I put an A there, I had that on my brain, hypotenuse. And what we're actually solving for is the length of the opposite side, which is called A. Well, cool, that's sine again. Opposite and hypotenuse, so sine of the angle 55 equals A over 4.8. Nice thing about this one, yeah, we can solve it the exact same way as the last one. 1A is A, 1 times A, and we would get 4.8 times sine of 55. Cool, that's the same thing as multiplying both sides by 4.8. 4.8 times sine 55, rounding to the tenths place, A will equal 3.9. Okay, last but not least, we have solving the triangle. Remember what that means? That means all angles, all sides. This is where we did our box. Measure of angle A equals, measure of angle B equals, measure of angle C equals. Then little a equals, little b equals, little c equals. Putting in the given, well, we have angle C is 90. We've got to get the other two. And then little a is going to be over here, little b is going to be right here, little c is going to be there. So b is 9, c is 16. I'll go ahead and start off with our Pythagorean theorem, take care of that right at the beginning. A squared plus 9 squared equals 16 squared. The key is that hypotenuse has to be the loner. So we'd have a squared plus 81 equals 256. Subtracting 81 from both sides, we get a squared equals 175. Square rooting both sides. And then rounding to the tenths, we get 13.2. For the decimal approximation for that side. The exact answer for that side would be square root of 175, but the instructions on the side just say round to the tenth, so you're giving decimal approximations. Okay, now we'll pick an angle that we want to solve for. It doesn't matter, A or B. I'll go ahead and pick A, so that will be my reference angle. We'll want to use what's given to us. Well, coming from A, that's going to be the hypotenuse, and this side is going to be the adjacent. So, I have the hypotenuse, I have the adjacent, cosine. So cosine of my angle is equal to adjacent over hypotenuse. Now on this one, unlike the last problem, last one I had like sine of a number, sine of 43. This one, and I wanted to get rid of that whole chunk. This one, I'm just wanting to get rid of the cosine, not cosine of a number. So we remember that the way to do that is do the inverse function to both sides. A is equal to the cosine inverse of 9 divided by 16, which is 55.77, rounding to the 10th place. 77 would be 55.8 degrees. That's a 55, not a 65, my pen. Ugh, I'm having issues because it's almost midnight. Okay. Now, yeah, you can go ahead and do the trig if you want, but it's almost midnight and I'm tired. So I'm going to go the easiest way. Say, well, all three angles have to add up to 180. Well, I know I've got 90 degrees, and now I know I have 55.8 degrees. So how much is left over? 34.2 degrees. And there's my final answer.